Assalamu alaikum students. Today we're going to study Pascal's triangle. We'll be studying the pattern and in the end we'll be connecting it with the expansion of binomial theorem. How can we use Pascal's theorem to solve binomial theorem? So first of all, we'll start with the 1. Always remember that at the edges in Pascal's triangle, we have the digit 1. There is a reason for it. For example, if Mr. M wants to reach at this level, this block, there is only one way of, there is only one combination or one way that he can go. Similarly, if he wants to, this Mr. M, if he wants to go to this level, there is only one way that he can, there is only one path that he can choose. But for this level, he can either go from this way or he can go from this way as well. So there are two ways that he can, two routes that he can choose. So I'll write a 2 here. Same goes for these, all these green numbers. First of all, I'll fill in the edges, and then to reach at this level, there are 3 ways. And you can figure it out without, solving the puzzle. You can figure it out by adding these two numbers, 1 and 2. To reach at this step, Mr. M has 3 ways. 2 plus 1 is equal to 3. To reach at this level, there is a combination of 3 plus 1, 4 ways, 4 different routes he can take to reach at this level. Now for this level, it's 6, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4, 5, 4 plus 6, 10, 4 plus 1 is 5. Similarly, for this level, there are 20 ways, 15, 5 plus 1 is 6. All right, so this is how a Pascal's triangle is made. You add up the numbers. These two numbers will be added to complete this Pascal's triangle. And I've told you the reason why you add these numbers, because there will be 20 different ways through which Mr. M can reach at this level. Now, how can we use it to solve the binomial expansion? Now, monitor closely. This is level 0. So if we have an expansion like this to the power 0, anything raised to power 0, we get a 1, right? First binomial theorem has been solved. Now move on to the second binomial theorem with power 1. When you solve it, you get x plus y. So the coefficient of x is 1. You can see this coefficient, and coefficient of y is also 1. This is y, right? Now let's solve it for x plus y square. You know that in order to solve a binomial theorem, you'll start with the highest power of x. The coefficient of x will be 1 in this particular case, plus I'll subtract 1 power from x and I'll add 1 power to y. Here it was y raised to power 0, right? So I've added 1 power to y and the coefficient is 2. Plus, I'll keep on subtracting the power of x and adding the power of y. So I'm left with y square, and the coefficient of y square will be a 1. Now let's solve it for the equation x plus y raised to power 3. I'll start with the greatest power of x, and 1 is multiplied. Secondly, 3x squared y plus Again, we need a 3xy squared plus y cube. You can see the pattern. This Pascal triangle is determining the coefficients of x and y. So in order to expand x plus y raised to power 4, we'll do the same. You will start with x raised to power 4 plus 4x cube y plus 6. 6x squared y squared plus 4xy cube plus 1y4. So without using a binomial theorem, we are able to solve it with the help of Pascal's triangle. I thought it was a very interesting connection. That's why I've shared it. All the best. I hope you've understood it. Allah Hafiz.